Hi class, welcome to this new video of tutorial 11 focusing on Laplace transform, and here we want to solve question 2. You are asked to find the Laplace transform of each of the 5 functions. Now, as a solution, let's have a look on the first function. Let's say you have f of t equals to t 3t power 4 minus 4 sines 2t, and we are asked to find the Laplace transform of f of t, which is equal to Laplace transform of t plus 3t power 4 minus 4 sine 2t. Now, it is important for you to realize that the Laplace transform is a linear function, so we can use the linearity over here to say that it is equal to Laplace transform of t plus 3 Laplace transform of t power 4 minus 4 Laplace transform of sine 2t. And then using the Laplace transform table, we know that the Laplace transform of t is 1, right? Laplace transform of t is 1 over s squared plus 3 Laplace transform of 4 factorial over s power 5 minus 4. Laplace transform of sine 2t is 2 over s squared plus 4, right? Therefore, the Laplace transform of f of t is equals to 1 over s squared plus, right, 3 times 4 factorial of s5 minus 8 over s squared plus 4. Okay, so that's it for the first case. Let's have a look on the second case where f of t is equals to e power 2t times cos 3t. Now, you are asked to find the Laplace transform of f of t, right? So it's the Laplace transform of e 2t cos 3t. Now, you see that here we can use the first shift theorem, right? That says that if you find the Laplace transform uh, of f of t times exponential et times f of t is simply equal to the Laplace transform of s minus a, right? So, and in this case, we have that EAT here is e power 2 and f of t is cos 3t. And we know that from the Laplace transform table, we know that the Laplace transform of a function cos at is equals to s over x squared plus a squared, right? So we can therefore, and here we have 3 cos 3t. We can therefore apply the first shift theorem over here, which will equal to the Laplace transform of the function f when considering the shift s minus a. So then I can therefore directly have that Laplace transform of 2t cos 3t, right, will be equal to, instead of s, I'll shift to s minus 2, right, and then I will have s minus 2, right, yes, square plus 9, right? So that's the case. So let's have a look on the third, where we have f of t is equals to sine square t, and here we can use a trigonometric transformation to have that is equals to half minus half cos 2 theta. Therefore, the Laplace transform of sine square t equals to the Laplace transform of half minus half cos 2t, right? So this is equals to half of Laplace transform of 1. I'm using the linearity, right, of the Laplace transform cos 2t, right? This is well known. This is half, right, times Laplace transform of 1, which is 1 over s, minus half times Laplace transform of cos 2 of cos 2t. And we know that, so this will be s over, right, over s squared plus 2 squared, right? So this will equal to 1 over 2s minus half times s over s squared plus 4. So this is the Laplace transform of the function. And when I look at the case D, and f of t is equals to 10 e power 3 cos t sine t. Now, and we this can be written as 10 times e power 3 times half times 2 cos t sine t, right? And we know that this here is equal to sine 2t. So this is equals to 5 e power 2t 3t sine 2t. Then, so the Laplace transform of f of t, therefore, will be equal to 5 Laplace transform of e3t sine 2t. And right here again, we will use the first shift theorem here and applying the first shift theorem directly, right? So if we apply the first shift theorem directly, um, directly over here, we will have that is equal to 5, right? So we put 2 here for the Laplace transform of sine, right? 2 minus s. Instead of s squared, you do the shift, you put the minus a, the 3 here, minus 3, right? Square plus 2 square. So this is equal to 10, right? Over s minus 3 square plus 4. So that is the Laplace transform of the function. And lastly, if we have e, which is where f of t is equals to 1 plus e power 2t square, I can apply the distributive law, right? And I have 1 plus 2e power 2 plus e4t. And then I can find the Laplace transform of f of t there, which is Laplace transform of 1 plus 2e2t plus e4t. Right. So applying the linearity of the Laplace transform, right, which is 2 Laplace transform of e2 plus Laplace transform of e4t. Now this is 1 over s, right, using the Laplace transform table, plus 2, right, I can directly find the Laplace transform of this function. It is well known. So s minus 2 plus 1 s minus 4. So this is the Laplace transform of the function. So I hope that this video has been helpful to you, and that from here you can confidently address the following question of the tutorial. Thank you very much.